Okay, so today we are going to go through the second part of software testing and leave the restraints of methods to the last lecture next week. Next week we will be having the first hour as a discussion on what are the restraints or how the applicability of different methods is limited in organizations. What are the hidden agendas of using an agile approach or developing your software processes. But today we will be going through the rest of the software testing part. So as a quick reminder, last week I started to talk about software testing, and we covered some of the testing related aspects on the organizational side. This data I'm presenting here today is collected from various different companies, mostly from the 12 small to medium national and international companies, a couple of larger companies, one government agency also involved. If there's also some survey data from 31 organizations, and additionally we did some validation interviews with 10 additional companies. So overall the observations here, the things we presented in the slides come from a number of various actual real companies. They are not from books or anything. So the idea is that actually testing and software process are more involved than with the original old style waterfall approach, where testing is more or less one of the latter phases of the development project, meaning that the testing starts somewhere around implementation. It's mostly done when the implementation is finished to ensure that everything works as intended, and during the launch and upkeep the testing is done. Well, this is the view on the testing that usually exists. This is also the most technical part of testing. Of course, also this activity of testing exists. Most of the physical tests, running test cases and stuff like that, is done at the testing phase. But actually what this project from which this data is collected wanted to approach testing from more a wide perspective, meaning that basically we include all the design decisions, pre-testing things, development of testing environment, making an analysis on what sort of test cases we have to use to actually be able to validate the data, and overall everything related to quality assurance, from the definition to design, in implementation, during the testing work, and launch and upkeep. More or less saying what, where, who, why, when, and how the testing and quality assurance is done. So overall, considering what sort of stuff we want to see, or what sort of things are related to testing activities, even outside the actual testing phase, which is the phase coming after implementation, we identified several factors such as testing tools, testing methods, personnel, test case design, selection, quality criteria. The testing tools, for example, are something that has activity way beyond the actual testing work starts. We have to create the test environment, ensure that our selected tools actually support the framework platform like PlayStation or the programming language we are using in the project. Also with testing personnel, do we have a person who knows something or enough about the platform? Do we have a person who is capable of using the existing tools? If we have to have new testing tools for, let's say, test automation, do we have to have some course or training material for our testing personnel? These sort of things. So overall, many things. And today I'm returning to the qualitative, sort of observational results made on the software industry. We knew that based on last week's results that the Finnish organizations offer on average 75% of the testing resources needed for optimal testing work. We also know that on average around 30%, a bit less than that, but around 30% is devoted to testing work, which is more or less a situation where testing work can be done efficiently or sufficiently in almost all organizations, and that the resource restrictions or the amount of people available for testing isn't such a huge problem in most of the organizations. So many aspects are more related to management or willingness to do the necessary decisions to allow testing work. So, which leads us to the first observation on what's actually problematic in testing. So, what are the areas that organizations consider that, okay, this is in testing something that we are unable to do? So, the three things came into most people's mind. They are test automation, agile development, and outsourcing. The test automation means that there's a software tool or software system which is built to automatically go through the modules and conduct unit tests for those modules to see that they still do what they're supposed to do, or see that if one new module or part is integrated to the software project, that everything still works as intended. It's more or less meant to be used as a quality assurance tool. And in most organizations, the problem was that even if the organization wanted to have test automation, it's actually quite complicated piece of software. There's simply not enough money or time or willingness to actually create good test automation. There's an order for people conducting testing that you should automate these cases. We don't have time to wait a couple of days each time we want to do integration or, well, basically anything. But on the other hand, there's no money involved, enough money to upkeep the system or pay the bills or handle the costs of actually creating automation. There's also a problem with the automation that actually it still requires the human observer. So even if we use automation, in some organizations it was considered more or less irrelevant if the organization wasn't doing highly iterative development. They considered that the automation still requires the human to observe things, so they might as well conduct it manually when they were about to release new version, so they test everything by hand. Okay, so test automation, it's difficult, it's costly, it's actually more complicated to implement than most people would understand. The second one was an agile development. One thing I talked about 2 weeks ago, and that's actually, that was a real hype term 5-6 years ago. So almost every organization which had the possibility went for agile development. But the actual problem with agile development and testing is that the agile development needs management which actually understands what they are doing. So from the viewpoint of testing, the agile development was considered really problematic in some organizations because the featureitis happened, meaning that the organization kept introducing late changes to the software, adding new features, doing all that sort of things to get the customer to pay more or customer more happy. Because, but on the other hand, it doesn't work that way because we still have to test all the late features. Also, contractual obligations in many cases meant that the organization made an agile development approach, but still, because that was trendy, that was sexy, but the organization still had to do all the waterfall and traditional approach documents and basically do everything twice, once for their own agile approach inside, and then to show the customer that, okay, we are still doing stuff like this. Well, anyway, that's the second problematic area. The third one was actually outsourcing. In many organizations, the way to document things was actually a bit, well, loose, to say. So we have huge amount of tacit knowledge, meaning that the knowledge that only existed in the heads of the people who developed the software, or people who maintained the software, or people who had tested the software for several years. So the outsourcing or using outsourced resources, any sort of service for testing, was actually a problematic for companies simply because they didn't have things documented. Even if they wanted to buy something like a test expert or test consultancy to test their product, they were unable to do so simply because they didn't have the documentation to get the program outside their own development organization without sending someone with the software to actually explain everyone what was going on. Well, there's actually a couple of interesting features here, because outsourcing is also something that was separately mentioned, that the companies did use outsourcing, but they did a bit differently than people would usually expect things to do.
Excuse me?
Yes?
About outsourcing, I'm tending to think maybe if you outsource, maybe it's a system. The system is supposed to come together with its documentation. So in this case, I think documentation should not be a problem when we are talking about outsourcing.
Yes, well, that's actually the one thing I was talking about. Basically, the companies which were using outsourcing, they didn't do the documentation, they didn't have any clean interfaces or module interfaces or stuff like that, but they just brought people in. They contacted test consultancy companies and they hired basically people, or insourced, as they say, people to get more resources or get someone who's really good at test automation or stuff like that. But that, of course, required that the test company they were working with would do something like that. Let's say, well, not solely internet-based services, but something like test automation. Some test automation companies actually offer this sort of service where you send some sort of an interface description or some description of your system, and they build your general framework for doing test automation and things like that. But if you don't have any documentation for specifying anything, or if you don't rely on that specification, then you are more or less screwed if you want to buy something for your development. Okay, but anyway, so what were they actually thinking about? What should they do? Well, many companies said that maybe we need some new tools. Some companies also were saying that maybe we need more automation, and some companies said that our documentation needs some focus, or we need to do more detailed work, or we actually have to start doing the documentation. One thing actually interesting in these observations is that they are all kind of generic. They are all sort of things that you could just throw out of your head when you have absolutely no idea or how to solve most of the problems. The idea to get a new tool, for example, is of course important in some cases when there's a obvious flaw in your infrastructure. Like I said on the last lecture, actually almost half of the companies interviewed for the survey didn't have separate system for reporting and managing bugs. So some sort of a bug tracing tool, bug tracing database, Mantis, or whatever basically would be an improvement for them. And that sort of a tool acquisition would be a really good thing. Also, new tools, something like more integration between the development engine and the bug database or reporting system, so that when you want to create a report or collect data or report an error or do some list new bug basically, you could get some automated transfer of results, so you don't spend the first 5 minutes copy pasting standard stuff from one tool to another. These sort of things. And that's actually something that should help focusing on the actual testing work. The test automation itself, the companies which already didn't try that and run into a problem, the companies which were new to test automation considered that would be something relatively interesting, would help them, but still some of the organizations on this area were clearly just going to run into this problem. So they wanted test automation, but they didn't have idea how to actually use it efficiently. So regression testing, of course, unit testing, during integration, of course, but still there were some things that the companies wanted just generic automation. With the documentation, there's actually a couple of companies which were having problems with the fact that their partners or development teams on the other side of the globe or another nation actually use different document template. So if you wanted to use their data, you had to convert everything or look for the data, or actually even simple things like how the date is marked down in different countries sometimes is problematic. If you have, for example, some old documentation, I can try to draw you a picture of the problem here, because if you don't have documentation standards or any sort of an agreement on how to report things. Let's say that we are trying to say that it's the 3rd of February in 2001. So that's the day we want to mention. Okay, so if we use this sort of approach, it's okay. But shorthand 03, 02, 01. Okay, so the 3rd of the February in 2001. But that's actually fairly simple: day, month, year. But we actually already know that on some countries it's year, month, day. So it's 01, 02, 03. This so that if you are naming your files this way, it's actually keeps continuously running downwards because the first number is the most meaningful one. But people coming from this culture, of course, reach it. That's okay. It's the first day of February in 2003, or some similar problems. Some countries actually use really also use month, day, year. So it's 2, 3, 1. Okay. So this sort of a problem. So all these are simple examples of yes, because this can be a real problem, especially if there's no strong version control. So, and you have several multinational team, multicultural team, and you are just digging through some repository trying to find the newest version of the module which was developed 6-7 years ago, when none of the people actually participating in the development work no longer work in the company. So these sort of problems cropped up in some organizations. Okay, and still otherwise more simple stuff, like always including the contact information of the person who made the module, contact information of the team that did the integration, these sort of things. So if the testers or, basically anyone run into problem, they could know who to call. Of course, with less than 10 people, it's trivial matter. You just yell in the room, who did this buggy piece of, software. But if we are talking about large company, which because of, non-disclosure agreements I can't name, but used to make mobile phones in Finland, has several hundred people participating in one project. Of course, you can't find the person who knows about that particular part, who made that part, or if it came from outside. Well, anyway, those sort of problems were quite usual. And those sort of enhancement proposals were actually the most important things to enhance the organization. So I mentioned that the companies don't use outsourcing in a sense that they can't order stuff like custom built test automation suite or things like that simply because they lack documentation. They have tagged information, sort of things that they just can't acquire the expertise. Of course, that's not entirely true. There was outsourcing in testing work, but it's more or less limited to the companies buying stuff into their organization and then adapting it to their use. For example, module acquisition. Something like PDF generator, virtual printer that creates PDF files. Some module interfaces. Some implementations of open source systems, that sort of things. They were actually easy things to acquire. Okay, so we need to have PDF output of our system report so we can license ourselves a virtual PDF printer. Simple as that. Or something fairly similar. That was actually the major channel, or more or less only channel, for open source resources to find their way into the actual products. Because with the open source resources, the companies didn't have anything against it. It's nice if someone has actually solved your problem, so you don't have to spend time doing it. But still, you have to go through the entire open source module so that you know that there will be no surprises or security risks or anything like that in that particular part. So, only when there was real need and there was a really separate module or component or something that was fairly independent, it was easy to use open source solution, since we knew that it can't it's easy to just see or demarcate the area where it can go and, well, use that. Okay, so, but that was actually for open source development one of the, the easiest way to find itself into the corporate world. The insourcing resources means, or like I said just earlier, that the companies didn't send their software outside their organization, but they brought people into their organization. So something like additional testers, real high-level experts of platforms, mobile systems, handheld game consoles, or some embedded software system specialists were actually brought into the organization by insourcing them, meaning that they were under contract for that one particular project, and that was actually, the way they could get more resources if they needed those people. And these insourcing resources actually went beyond just having more testers or more focused testers or people doing quality assurance work on separate, really focused platforms. It also went to acquiring actual, general knowledge into the organization. One company, for example, had a software tool which helped the local farmers to fill out the European Union reports and applications for grants and stuff like that. So, of course, what they needed for that project was not only a specialist or lawyer or accountant, actually, if I remember correctly, which knew how to fill out these forms. They also had to have farmers who were actually able to tell what sort of information the system actually is using. So they didn't hire farmer, they didn't hire accountant or lawyer or anything like that. They just bought 2 people or a couple of people to do sanity testing or sanity checks and legality checks for the system output, knowing that it would actually produce correct information or fill out the form correctly. Also, on other areas, basically any area, experience, knowledge on different tools, different systems, people who know about the target audience or people who actually represent the target audience, these sort of things. So using completely external service was more or less the thing the companies were unable to do or unwilling to do, because they couldn't do it because of contractual reasons, or they simply didn't have the sophistication of their system that would allow them to buy anyone in. So, the agile methods were considered problematic. This I actually talked about earlier. The agile methods are, they aren't that usual. I mean, there's some books that say that the traditional approaches are dead and gone, and the agile rules and stuff like that, but that's actually not true. The agile methods are really good when the companies are doing small projects, but actually the main development cycles are more or less traditional approaches or the Scrum sprints are iterations are so long that they are within one sprint led with the more or less traditional approach. The more extreme agile approaches like test-driven development or extreme programming, they are nice ideas, but no one was actually using them simply because they are also really vulnerable to people leaving project or, well, customer becoming nervous with the approach. But the agile approaches or agile practices, daily builds, daily meetings, code reviews, pair programming, using stories, like basically storyboard on designing software, things like that, or stories on how people would be using our software when it actually exists, types of things, were actually quite common. Even companies doing really or fairly highly critical software were using agile practices, even if their development method was more or less traditional approach. Also, well, the product quality, agile approach didn't have really that much difference on product quality. If it worked, it was nice, it worked just fine, but it was not a clear indication of higher quality or stuff like that. The most important part of using agile method was that the customer was more present. If you had a customer who had a strong opinion or clear idea on what they actually wanted, then it improved the product quality. And that was also the important part of agile approaches. Instead of hiding the customer behind wall of middle managers and lawyers and stuff like that, you could actually call someone and ask things. So, a couple of more, detailed things. So, in general, the amount of testing resources, many books, like 5-6 years ago, were talking about the fact that the companies have problems finding testing resources or testers or people who know about testing, or they don't hire testers because the developers can fix their own bugs. Well, that's actually not true anymore. Like I said earlier on the course, in our project, or based on our observations and after that many observations from other countries conducting similar studies, there are actually no problems finding testing resources. Larger companies are actually willing enough to send their own people to training if they need to have more testers. Some small companies or some small companies which have highly focused area, like they are developing software for their own hardware system, sometimes have shortcomings, but that's because in small companies, more or less because the company can't pay or company can't afford more muscle in their testing work. On the highly specified areas, the problem may be that the company has already hired all the experts for that particular area. So they run into shortcomings simply because there are no people available anymore. So they have to train someone or go really far into the world to actually find one, and then try to convince them to work for them, or in some cases move to Finland where it's always cold and dark. So that's not going to be a problem. That's going to be a problem for some companies. On testing tools, the companies used, of course, test drivers, test stubs, meaning the replacement parts before the module exists. But that's just, well, common sense really. If you want to do some testing, you have to have some sort of a replacement part which plays the role of module that doesn't exist yet. Databases for bugs, things like that, are fairly common, but most of the testing work is actually done with the development tools. So actually, if you want to train testing work, then you actually have to train yourself programming, because the testers in many organizations are also people who are, well, not responsible for doing development work. That the code is done by someone else, but they have to be proficient programmers enough to understand why the code doesn't work, or at least explain to developers what might be the origin of the problem, so that the developers can go into the module and break everything to find the missing part. So on how the testing is then done, there's actually fairly interesting table on this. So testing can take as much money and time as you can throw at it. So we are always in a situation where we can't test everything. We are always in a situation where we are either running out of money or time, simply because complete testing is impossible. So how companies do actually avoid this situation? Or more importantly, how companies prioritize their test cases. So the test case selection strategies actually were really interesting, because the companies have usually two strategies. They are either risk-based or design-based. This means that the risk-based approach is used in companies which have fairly limited amount of money. They are prioritizing their test cases based on how much it would cost if this part broke down when our customer is using it, or how many problems will this part cause if it works unsatisfactorily. So the risk-based approach tries to use limited amount of money as efficiently as possible. The flip side of the coin here is the design-based approach, which was more or less used in large companies which have more than sufficient resources to cover all the expenses of one software project. Their approach was more or less, how can we, what do we have to ensure that the product meets the requirements and use as little money as possible, or as little money as required. So these two approaches were basically all that mattered for most of the companies. All the different selection criteria, or all the different way to classify problems, are more or less just extension of these approaches. But the risk-based approach, how can I use my money most efficiently to cover largest parts of the software? And the design-based approach, how can I cover this entire software with as little money as possible, are actually the two things the companies really cared about. So, going a bit backwards, and one part of the study, explorative testing, was also interesting in this sense, because the explorative testing, meaning that the testers are given time to just use the software and try to break it in innovative and creative ways, was also something that the smaller companies and some of the larger companies actually said that yes, of course we do it. It's the easiest way to find out if there's really simple and stupid mistake in the software. But on the other hand, some companies went and said that, oh, no. Explorative testing is just idling time for the testers. We aren't using that because it's undocumentable, unprofessional work, and it's just, testers surfing on the net and saying that they are actually doing something when they aren't doing anything. So explorative testing, you will probably heard that term in future, was either one of the most important ways we ensure that our software works, or something that lazy people do when they don't want to conduct the required use case lists of tests. Okay, so error analysis and classification. Well, interestingly, most of the companies were actually interested about how critical our problems were and stuff like that. But more interestingly, actually, some of the companies weren't. So, overall about standards. This course talks a lot about different certificates and standards and approaches and defined models and methods and all that sort of stuff. But you always have to remember that they are just frameworks or ideas which are more or less just collection of best practices or practices that are considered to be more beneficial than harmful. So in this case, there are several standards for testing. ISO IEC 29119 and also the lifecycle model 15504 are two models where testing is actually defined to some degree. But there's also ISTQB certificate and stuff like that for software testing, but that's actually not that common. Some companies do have, for example, the ISTQB certificate, but most organizations don't really follow any standard. They just take a collection of ideas and, try different things and use what actually, works for them. Well, they should because, if you are following a standard which doesn't suit your organization, then you are using the standard wrong, or the standard may be actually even more harmful. But still, interestingly, many organizations were, at the same time when they were considering that they might need some new tool or new approach or do more documentation or streamline their approaches, they also weren't that interested or weren't exploring into the possibility that someone might already have been solving these same problems. The customer participation, what I want to mention from this slide is that the customer participates on the design work and customer participates on the acceptance testing. And most people actually prefer it that way. Most people say, not most, many people or many organizations indicated that they actually find it really annoying if the customer keeps calling them or keeps telling them how to do things or what to do or how to solve some problem if they weren't the ones asking for help. So even if many organizations many methods or many approaches, especially on Agile, promote that we have to have the customer present. We have to do this with customer, we have to do that with customer, we have to do wine and dine with customer and all the other nice little things. But still, if you talk with the developers or project managers, they say that they don't want the customer here. We don't want the customer in our organization simply because we want to have some resemblance of management and resemblance of, well, doing things our way here. The customer is really good thing to have when you want to have more information, but we don't want them in our premises. Or if the customer keeps calling us, then it's actually annoyance. But anyway, in some industries, like games, for example, of course you want to have the customer there. You want to have the customer to be really pleased with the product. Well, not saying that the software industry doesn't want, but still, you don't always have to believe the saying that having customer present is always better. So, following the 29119 model, which we discussed last week, where the organization has their internally set test strategy and test policy, and the projects have their own test plans and all the other activities. And we also had a definition for quality being the eight different attributes, which combined are the end product quality. We were actually testing out on the survey then what are the actual aspects in the development work or testing work that actually enhance the end product quality, or on the other way around, what sort of things make the people making the software believe that they are making better quality than earlier. So there's actually three things here. If you trust your customer, if you trust your developer, if you are certain that the customer isn't malevolent or isn't trying to hide something from you, or just if they trust you, if they want you to succeed. It's a terrible marketing term, but let's go with that. And if the organization does the testing work with a similar approach to the standard, doesn't mean that if you follow the standard your quality is better. It means that the standard and the model has aspects which seem to enhance quality. Organizations which are conducting by themselves similar practices that the standard defines tend to believe in their own quality more than companies which aren't. Also, the companies which know what sort of quality they want actually are able to achieve better results. But interestingly, the 8 different attributes, the functional suitability, reliability, performance, operability, security, compatibility, maintainability, and transferability are, there's really no clear winner here. Actually, in most organizations, all of these attributes are at least somewhat important. We conducted a questionnaire where we asked how important you consider this attribute to be to your product, and the scale was something like from 5-point Likert scale, from not important, not very important, I don't care, important and very important, or something like that. But there was also a possibility to say that this doesn't apply to us. So we don't consider this attribute to be important at all outside the Likert scale. But it's still only 9 out of almost 250 assessments said that this attribute, like transferability from one platform to another, isn't actually important to our software. So and overall, all these attributes got fairly uniform assessments, meaning that if you want to have some sort of a universal quality, that what's always good quality. It's not so straightforward simply because there's in almost all software products so many different areas or things that all these quality attributes actually have importance to at least some degree. Also, fairly interestingly, there were no companies which were able to pick or select 3 or even 1 or even 3 their most important attributes. You would expect that some company doing highly critical software for maintaining something like railway logistics would always pick security as their most important attribute. But that isn't actually true. We interviewed project managers, software architects, developers, testers, and actually in some companies even upper management, and asked them to pick on this product they are making. They were all from the same product line. So if your first instinct is that, okay, we interviewed people from different departments, we actually were interviewing people from the same department doing different things. Okay, pick 3 most important quality attributes and put them in order. We actually got the result that only 3 companies out of the 12 we had the 4 interview rounds, some even 5. Only in 3 of these 12 companies first of all there was situation where all the interviewees picked at least one same attribute, all of them. Only in 1 company there was a situation where all the employees picked the same quality attribute as their first most important attribute. It was the reliability. But actually, on the other attributes, they were, they had different opinions. So, considering that I was just mentioning that the companies which know what sort of quality they want, what is the high quality of our product? This is really important stuff. It may seem like, okay, of course everyone knows what we want or what sort of features we want, but that's not actually true. You have to identify, you have to document, and you have to communicate your selection of quality attributes. So what sort of quality do you prefer? Okay, so couple of last slides on observations in organizations. One part, of course, of software development, testing work, all the other things is that you have to be able to maintain your technological maintain your organization with the technological advancements, or if there's new upgrades to the system or new versions of software, you have to keep up with the system. So of course, sometimes your organization has to develop from your old situation to custom-made changes, or new needs, or new customers, or new types of ships, for example, if you are doing some maritime software. But anyway, we wanted to know how these organizations then develop themselves. Test process was the thing we were talking about mostly. Many organizations said that these observations also are actually, the same situation is with the overall process. Like, how do we develop our rational unified process or development process, what sort of things work and what don't. There's actually one fairly dominant observation here. So, how organizations develop their test processes? And the answer is they don't. They don't do it. Well, they want status quo. If everything works, if we can manage to pay ourselves out of the hole we have dug ourselves in, well, they don't feel the need to do development. Actually, this doesn't even matter what size of an organization you are in. Some say that small organizations develop their approaches to development or testing or marketing or whatever really more willingly because they are small enough that they can make changes. But that isn't always true. You can become accustomed to your current situation or institutionalized to your current processes, even if you are a really small company. And that's more or less probably because if you're conducting process development, or it's of course away from the actual production work. You aren't producing new product or doing productive development work if you are trying to learn how to manage your software project with new tools or trying to learn new programming language. So many companies simply don't do that. And actually, only if the new concept is fairly close to the existing process or compatible or comparable, that's when there's a good chance that the companies adopt that approach. And I guess that's actually one of the reasons why Scrum is fairly popular, for example, in software development. It's easy enough to implement in an organization which has earlier done month-long mini waterfalls to get new versions of the software in their larger main development process. So, how organizations develop their processes? Well, they don't tend to try out new ideas. There's actually one big worrying problem here. We were interviewing one company which was a test consultancy as their main business area, meaning that they were a company conducting testing to other companies or organizing testing work or doing consultancy work for companies so that they can find out the areas where they need to improve or where they need to get more resources to improve their quality. And even that company didn't always try out new ideas. So even if the companies which are supposed to be telling other companies what to do isn't trying out new ideas, then I don't know what to say, but that's actually something we observed. Okay, so if the inconveniences, here meaning the old style documentation, unsupportive tools, releasing software to platforms which aren't commercially viable anymore, also you have to adopt new system. If these inconveniences are too large, then there's some process development. But even then, there's actually more or less the approach that what's the minimal change we have to do to return to productive work. So you have to consider it this way. The companies don't usually do positive reinforcement in their development cycles. They don't develop themselves to be more efficient or be more up to date or be more cost efficient. They develop themselves because they have problems and it's simply impossible to continue working with the current approach. And that's, a bit sad actually, but that's how the software industry works. So, actually, those were the results from the companies we were interviewing and some observations in general. There's actually one fairly simple way to develop or assess your test processes. This is more or less aimed towards an industrial audience. I'll go through the main idea here, so you can conduct this if you want to, in your company or when you are doing training work somewhere. But the idea is that actually the problem usually with the self-assessment is that if you want to have an approach with a test maturity model or have a review of your organization, it's usually really, really complicated. And it's time-consuming, it's expensive work. But there's actually, you can do it more easily with the 29119. Like I said earlier, there's a number of processes there. There's an organizational level, organizational process, which is more or less that how the upper management is conducting or steering the testing work. There's project level management, test management process, which is how the overall work in the project level is managed. Test planning process, test monitoring and control, test feedback process, and different sort of things to measure from the actual testing work. There's also a fairly simple way to assess the maturity level of these different processes. So, is the organization doing something on that area? Well, that's level 1. Is the organization doing things cost effectively? Well, that's level 2. Does the organization try to lower risks involved in that work? That's level 3. And is the organization doing optimization on their process? Or more or less, is the organization following practices which are similar to this standard? That's level 4. So overall, comparing all these different areas of work, how the test plan is made, how the test work is monitored, how it's controlled, what sort of feedback is collected, how the upper management or organizational management supports testing work, how the testing team conducts their work, how the testing frameworks like environments and things are set up. Are they defined or designed beforehand, or are they just something that was scraped together in the morning when we had to start the testing work? So more or less we get the maturity levels here. So that one there. So basically we get a profile on our organization. We have something like 5 or 6 people here. We have test manager, who's project level test manager, tester, possibly developer, someone from upper management, and a couple of hours to go through all these 7 things so that they can agree on what maturity level they are from. The maturity levels are from the test improvement model, meaning that it's the same thing I said just before. Are we doing something? Which is documented or generally agreed that how it's done? Is it cost efficient? Is it avoiding risks? Is it optimizing things? So okay, we get the profile, and based on that we get few things. First of all, we know the general maturity conformance level of the organization with the standard, and we also see the worst performing areas. So expanding on this, if we collect the reasons why we set something on one place, then it's actually fairly simple to just collect a couple of the most important things that could be done to take away these problems and possibly take the organizational process mentioned as an OP there to the level 2, which is clearly the most problematic area in that organization. If we have one person from the upper management, one person from the project level management, one developer, tester, a couple of people, 4 or 5 people from different levels, and we come up with this sort of thing, we know that okay, so we have to on the organizational level, define more clear policy, more clear strategy, actually have someone oversee that if the organization wants something, the projects actually have the resources or tools to do so. Not very problematic. And we actually tested this sort of profiling work in a couple of companies, and most of the feedback was positive. So this is not just me. I'm not trying to sell you snake oil and silver bullets here. Someone else actually also thought that this is a fairly good idea. So, conclusions. So I've been talking about testing work for 2 lectures now. So the 29119 is a generic process model which more or less fits all the different software testing needs. Of course, if you are running a 3-man company developing a game for Android phone, then you probably don't have to have organizational test policy or test strategy. But still, there's some things that you probably should have in your test plan, or at least in advance think that is something that we can ensure that works, on how we can do it. So this organizational process, policy and strategy, they more or less define the objectives, the methods, and the resources the normal projects use. The projects themselves, they try to do things as the strategy defines, and from the objectives, methods, and resources, we go to the actual test plan, actual test process, actually monitoring what we are testing, collecting the metrics of seeing that everything is done correctly or that the project advances, and controlling things if the things aren't working out. Also, if the infrastructure has problems, like the tools are out of date, we have testing tools which don't support our current programming language or programming framework, or there's a new version of Eclipse that breaks down the backwards compatibility with this other module we have, these sort of things that happen. Then you just give feedback to your organization, and someone should allocate money or have the idea that, wait, we no longer have this resource available, maybe we should do something. So overall, there's a high-level observation here that in a normal test process, basically everything affects the testing outcome. In an exceptional test process, outcome affects basically everything. This means that in testing work, everything you have planned, everything you have designed, every requirement you have gathered, all the tools you are using to do the development work actually has an impact on the testing and quality assurance. On the other way around, if you are doing testing and quality assurance correctly, everything you do there should also affect how you do things in the future. And more specifically, organizations, they don't develop their processes unless they have to. They actually ignore feedback if their organization considers that their current processes are good enough. But on the other hand, if there's real inconveniences, some new ideas, concepts, or approaches are sometimes adopted. And testing standards, in general, standards, certificates, training programs, they may not be widely used, but still they are a good place for organizations to look for more information. And even if organizations really don't use standards officially to a large degree, it's more or less a book of practices. They just adopt something that seems to be working in their organization. And if you want to do test automation, keep in mind that it's actually really useful, but only if you put enough resources and money behind it. And even still, it's not a frontline testing tool. It's not something you use to find new problems. It's a quality assurance mechanism which ensures that everything you did previously still functions. And yes, as I said actually at the start of this lecture, I cannot put enough emphasis on this observation that the companies put currently 75% of the optimal test resources into their current testing work, and they use 1/3 of their project time or time resources in testing work. It means that the problems with testing or problems with quality or problems with the outcome aren't in the testing work. It's in the management. It's the inefficiency of the entire project, of the entire process. And usually it's also something like missing the target audience, not gathering the correct requirements or making wrong assumptions on your customers. From the technical point of view, most of the organizations have enough resources to conduct testing efficiently. And, well, I guess that's that. So, with these parting words, let's see for the last lecture next week when we are talking about the restraints of methods or constraints of methods, meaning that we will be talking about the problems associated with everything I have said on this course during these 13 weeks we have been having this course. So, thank you. Yes?
What exactly does explorative testing mean?
Sorry.
What exactly does explorative testing mean?
Explorative testing means that you are